All right, guys, today we are going to be doing a lab, and the lab is going to be working with a chemical that most of us at some point in our lives have come into contact with in our kitchen, and that chemical is baking soda. We use baking soda for lots of different things. Some people use the baking soda in cleaning products. Some people use baking soda. They put the box in their refrigerator to help keep it smelling fresh in there, as it tends to absorb and neutralize odors. And we also use baking soda, like the name implies, for baking. Now, the reason that we like baking soda is because one of the neat things about it is it produces carbon dioxide when you start to heat it up. It goes through a decomposition reaction. So if we're looking here, we'll see that written on your lab are 3 possible decomposition reactions. So we have sodium bicarbonate, which is the chemical formula for baking soda, is decomposing, and in every single one of these equations, carbon dioxide is one of our results. The carbon dioxide is a gas, and that's what's important for baking. The idea is that if you read through the intro here, it's got a few different examples, but it's what gives our bread that light, fluffy feeling, right? So as it's cooking, this gas is produced, and the gas causes stuff to puff up. But what is the other stuff that's produced? What's the other stuff that's left behind? That's what we want to know. So which one of these equations works? And the way we're going to figure this out is through using stoichiometry. And so what we're going to do is we're going to try and basically recreate the environment that causes it to decompose, which would be an oven. So we're going to get a sample of baking soda, we're going to heat it up, it's going to decompose and produce a lot of carbon dioxide gas and such, and we're going to reweigh the products. And hopefully our stoichiometry will tell us exactly which equation makes the most sense. So looking at the scale here, let's make sure that was 0 before I put it on. It was. Our data table asks for us to get the mass of the empty crucible, so there it is. Let's record that. And then once we have the mass of the empty crucible, we're supposed to tare it. So I went ahead and zeroed it. And then it asks for us to just fill it up about half full. So we just need a few scoops of the baking soda. We just need to get a decent sample size so that we have a noticeable mass change. So it doesn't tell us exactly how much to get. So I would say that's probably plenty. We're about half full there. So my mass of the baking soda can be recorded now. And now what we want to do is basically put it in the oven like we would if we were cooking. So we're going to go ahead and take our sample, and we're going to move over to the fume hood here and cook our sample. So I'm not going to make you guys sit here for the whole cook. I tend to save you a little bit of that. There's not really a lot of anything exciting to see in this process. If you look at some of those products that we're making, they are basically stuff that we can't see. Sorry about that. New classroom. The gas shuts off if it doesn't get used for a few days. So, okay. So let's adjust that a little bit. Definitely too much gas on there. But what we want to do is start heating this thing up like we would in an oven. So we're just going to let this cook. And it doesn't really do anything noticeable. Occasionally we're just going to reach in there and we're going to give it a little stir. If we want, we can always move the flame out of the way so that it's not around our hand, and we can kind of break up some of the clumps that might be in there. Sometimes those clumps trap and sort of protect the center. Try and leave as much of it in there as we can. We might lose a tiny little bit of mass when we start stirring. We can see that on the tip of the scoop we're going to have a little bit left behind. Hopefully our sample size is large enough that it won't be noticeable though. So we're going to go ahead and let this thing cook. I'm pretty much just going to stand here, and every couple of minutes I'm going to do what you just saw, stir it up a little bit, and then let it cool. Alright, so we're back just to stir it up a little bit more. It's been about 5 minutes in the oven. And remember last time there was a little bit of white powder that was on the scoop. But the nice thing is now that it's been cooking for a while, it's actually taken it back. If you look at the end of that scoop, none of that white powder is left. It's not sticky anymore. Whatever it's turning into is not sticking to the metal, so we don't really have to worry about any loss of material from that. So we're going to go ahead, now that I've stirred it up, we're just going to let it sit and continue heating for a little bit longer, and then we'll let it cool. Alright, it's been about another 5 minutes. This stuff hopefully is as decomposed as it can possibly get. To be quite honest, looking inside of the crucible, there's not very much difference in what it looks like now to what it looked like then. If we shut it off and we just sort of tip it sideways, it's still just a white powder, but we're going to just set it down here. This is not a hydrate, so I don't need a crucible or anything like that, or a desiccator. We could just let it cool. On here, we don't want to set it onto our countertop because it's pretty hot. We don't want to wreck it. It's already looking bad enough, but in a couple minutes, we'll get our final mass. Okay, time for that final weighing. Pretty cool. Time for us to come back over to the scale, see if we can get the mass of what our product is. So we're going to get this to refocus, make sure that we're reading 0 on the scale. So my product and the crucible together weigh 25.98. So now it's up to you guys to take the next steps. So finish completing that data table, and then you have a few conclusion questions on the back side. The first thing is just a sort of a summary, why do we need the baking soda? But the next will be to actually write and balance some chemical equations, so for A, B, and C. So we've got them here in their written form, and we've been practicing with how to put these things into actual chemical equations. So you guys are going to go ahead and move forward with that. And then once you have it, take a look at those equations. What is the possible chemical or chemicals that would be in that crucible if we were working with A? And then that product that we think is in the crucible, how much of it would we expect to make with our starting amount of baking soda? So if we look back here, we started with 6.64 grams of the baking soda. So with that in mind, how much product do we expect to make? This is a theoretical value. So in theory, how much, according to this equation, should we have been able to make? And we can compare that to what we actually made and see if it makes sense. We're going to do this for each one, and then you're going to decide in the last step which one of these works the best with our stoichiometry and what we actually saw happen in the lab. All right, good luck, guys.